Hi, when you visualize your genome tracks in IGV, you obviously have to choose what animal it was, and for human it is the most recent version, GRCH38. And if you use data from the publication, then you also have to check which genome assembly authors used, and it should match. I used the right version. But if it is your data and you begin from mapping FASTQ files, then you should know exactly which genome assembly you have used. The history of genome assemblies of human and mouse can be found in a GENECODE, and you can inquire details. And then you see a long list of assemblies 38 starting from 2014, which are divided by versions. The latest is P14, and by releases the latest is 48, but there are also lots of different numbers. So they are all roughly the same, but yet different in some details. And then the question would be, alright, this is assembly from IGV. Can I compare it with my assembly downloaded from GENECODE and used for mapping? And the answer is yes, it is possible. What you have to do is you go, for instance, to assemblies 47 and then download basic gene annotation. So there are different versions, and basic is a smaller one. This one, alright, save. Of course you can try to load the downloaded file immediately, but better not, because first you better go to the IGV tools. There is a page, and then you do two things: first sort and then index. And you take GTF unzipped and say run. It will take a while, but then it says it's done. You go and say index, browse, sorted and unzipped, run. Again, it takes some time. Now it is done, and now you try it, load from file, and then again you take sorted, unzipped, and here we are. So that's the map of 47 assembly. Each is not the same. With the right click of the mouse you get this menu and options for visualization. This is collapsed option, this is expanded, and this is squished. You take whatever you like. You can also try to expand original annotation, but it will not change. The self-downloaded version is more detailed, and if you like it more, use it, and you can use both of them next to. But it's not yet all you can do with annotations. You can also go to bioMart and download something else, for instance enhancers. When you are in ensemble site, you go to bioMart and then you choose the ensemble regulation database. Human we have now, and here again we have another GRCH38 version. P14. Alright. And here we are looking for enhancers. Where to find them? In filters you can limit search by chromosome or coordinates. Here we need, this one. We need these features like CTCF, for instance, UMAP enhancer. Why not? Yes, and then attributes chromosome, start and feature type, and preferably directionality, but this I don't see. That's it. Results. Okay, we can live with this. Unique. Save to file. Go. Everything you download from bioMart will have a uniform name Mart export, so you rename it to, let's say, enhancers. CTCF and EMR. And this is almost a bed file, only the chromosome should precede the CHR letters, and then it should end with the fifth column directionality, and if we don't have it, we have to leave a dot in it, and then it will be a regular bed file. And we can do it in Python. In Python, this is a spider editor. You write a small script where you first define directory, call the file, this one, define the output file name, this one with a bed extension, and next you do this with OpenSF. That's a safe way of dealing with the long big files, one line at a time. Do not forget to skip the first line, the titles. You don't need them for a bed. Then you simply add CHR at the beginning and dot at the end with a tabulation. Then you create it. You save the script and go back to IGV. On your way to IGV, you can also check it in terminal. Then you say head enhancer something bad, and then you see it's a headless with all the columns you need for bed file. Should work. Now you are back to this screen with GATA2 in the middle. For convenience, you can always save session and open session instead of opening all tracks one by one. And now you add one more file, the bed one with enhancers. And here it is. This is the line of enhancers. That's how it works. To summarize, when you see GRCH38 symbol, which stands for genome assembly version of a human, you have to know that it's a family of closely related maps from which you can choose any version you prefer, for instance based on your own mapping business or extra information. And if you miss something, you can always try bioMart and find those tracks which you can transform into a bed file and load it to your genome viewer. Thanks until the next time.